All right, so here we go. Quadratic formula. X is equal to minus b plus or minus the square root of plus or minus the square root of b squared minus 4ac b squared minus 4ac all over 2a all over 2a. And so the quadratic formula will always work in solving quadratics if and only if a does not equal, do you remember?
0?
Yeah, that's exactly right. As long as a does not equal 0, then the quadratic formula will always hold true. And that's because if a was 0 here, then what would our denominator be? 2 times
Wait,
0 is?
oh, 0?
Yeah, and so we can't divide by 0 because anytime we try to divide by 0, that's undefined. So when, like if you had 2 over 0, we can't do that. That's undefined. We can't divide by 0. All right? So just as a warm-up, where does this B and A and C, I mean, it kind of sounds like we're doing Old MacDonald Had a Farm, right? With all these or all of these letters. Do you remember the standard form of a quadratic?
Isn't it like A equal? Oh, no, wait, no, that ain't right. That's something else.
A,
Um,
does that help?
A
AX squared plus
plus
B.
B plus C. BX plus CX?
So C is our constant, so it doesn't have an X, but you were really close. That's excellent. So it's the AX squared plus BX plus C equals 0. That's our standard form of a quadratic. What is the degree of a quadratic? Do you remember?
Nope.
So anytime we're looking for the degree, it's always the highest exponent. And so on a quadratic, the degree is what? What's the biggest exponent you see?
2.
Mm-hmm. So the degree is 2. And one thing that we know, anytime we're dealing with these types of formulas, whether it is a quadratic, which the degree is 2, or we could even do a cubic function, which the degree would be 3, or a quad function, which would be 4. However, whatever the degree is, whatever that highest exponent is the number of solutions we're going to have. So in this situation, we have a degree of 2, and so that means we'll have 2 solutions. And that's really what we want to look at as we expand upon the quadratic formula. We're going to talk about a very special part, just an individual part of the quadratic formula. So let's warm up, do an example with our quadratic formula just to knock the dust off the back of our head, right? And oh, get the sleep out of our eyes. So let's look at 2x squared minus 3x minus 1 is equal to 0. And the first thing we would want to do is we would want to label our A, our B, and our C. What is our A?
2x.
So it's only going to be the coefficient.
Oh, 2 then.
Yep, perfect. And what is our B?
3. Negative 3.
Perfect, excellent. And then what is our C?
Negative 1.
Yep, you got it. And so now we're just going to plug it into our quadratic formula up here. X is equal to minus B, so it's a minus 3. Boy, that could be a tongue twister, couldn't it? Plus or minus the square root of minus 3 squared minus 4 times a, yeah, exactly, times what?
-1.
Mm-hmm. All over 2 times what?
No, 2. Tongue twister. There we go. 2.
Yep, exactly. And so now we're just going to simplify it down. So we're going to simplify it down. We've got a negative -3. What is that?
Positive.
Positive 3 plus or minus -3 squared.
-6.
So a -3 squared is a -3 times a -3.
Wait, -9.
Negative times a
Positive
negative.
9.
Excellent. Perfect. And then 2 times a -1.
2.
Positive or negative?
Negative.
And then -2 times a -4.
-4.
So -2 times -4.
Oh, I thought you said -1 times -4. Negative. So it'll be 8.
Positive 8. Exactly, because that negative times a negative. So we're going to add 8. And then 2 times 2?
4.
There you go. So now we've got x is equal to 3 plus or minus 9 plus 8.
10, 11, 12, 13, 14, 15, 16, 17. 17.
Perfect. Divided by 4.
Mhm.
And we're going to split this apart because this plus or minus here tells us that it's 2 different ones. One of them is plus, one of them is minus. So we have 3 plus the square root of 17 over 4 and 3 minus the square root of 17 over 4.
Wait, is
And
that our answer?
yeah, that's our answer. There's no sense in going any further because 17 is a prime number. And so we can't simplify that radical any further. So we can just leave it in those terms, and that's our answer.
But you can simplify 4, can't you?
What do you mean?
You can, because you said you can simplify it and simplify it down, but you said you can't simplify 17, but you can simplify 4.
So, but 4 is not under the radical.
Oh, okay. It says we under the radical in order to get this.
Right. So the only thing, and if this was a different number, which you'll see in the next problem that we're going to work through, then we might be able to simplify this down even more. But 3/4 is as simple as it gets. And then this is an understood 1 right there. So 3/4 and 1/4, we can't simplify it anymore.
Okay.
All right. So how many solutions do we have?
Dos.
Dos. Yes. Sí. Sí, señorita. So we have 2, which agrees with our degree of 2 as well. Now we're going to look at a certain piece of the quadratic formula. And so it's called the discriminant. And the discriminant is b squared minus 4ac. It's simply that piece under the radical of the quadratic formula. So the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over, you remember?
2,
All
2,
over.
2A.
Yes, excellent. And so the discriminant is actually this piece right here under the radical. So right here. And that's a very important piece because it can tell us some information about the types of solutions that we're going to have. Now, last week, we worked a problem that had a negative under the radical. So like if in that previous problem, if it was negative 17, well, we don't know what to do with that yet. And I told you guys last week that in Algebra 2, you'll learn how to deal with a negative under the radical. But in Algebra 1, we're going to leave that thing alone. We're going to say, go away, shoo, bye, and not going to do anything with it besides just leave it as a negative under the radical. So this discriminant, we call this, it's an imaginary solution, so it's not real, which is the opposite of imaginary. Do you agree?
Yes.
So we're only interested in Algebra 1 in real solutions. So this discriminant, if you have b squared minus 4ac and it is greater than 0, then that tells us that we have two real solutions. And then if you have b squared minus 4ac is equal to 0, then we only have one real solution. And then finally, what's the other one that I haven't written down yet?
Oh,
Greater than,
yeah.
equal to,
Or less than.
yeah. If b squared minus 4ac is less than 0, then we have 0 real solutions.
Oh.
And let's just think about that, because like in the problem that we just did, our discriminant, what was under the radical, was greater than 0. And so how many solutions did we have?
2.
Mm-hmm. 2 solutions. Then if we have the square root of 0, well, that's equal to 0. And the only solution there, 0 times 0 is 0. And so there's only one solution, and that has to be 0. But then if you have the square root of that negative 17 under the radical, that's when you have no real solutions. And that's what we talked about up here with this negative 17. No real solutions because it's less than 0. So if it's a negative, it's less than 0, and it would be no real solutions. Good?
Mm-hmm.
All right, perfect. So let's try